Hi, today we're going to be doing functions from Additional Mathematics Chapter 2. So to start off, we have to be able to differentiate between a relation and a function. So a relation is any set of points which connect two variables, for example x and y. So the examples include y equals 2x plus 3 or y squared equals 4x minus 4. And a function is a little different to a relation. A function is a relation in which no two different ordered pair have the same x coordinate. So we'll learn more about it in the next few slides. So basically what I'm trying to say is that every function is a relation, but every relation is not a function. And so examples include y equals 2x plus 3 or y equals 4x squared plus 3x minus 4. The next part is mapping. So as you can see the diagram, this is called mapping. This would be the x coordinate values and this would be the y coordinate values for all of these. And a relation is called a function if for one value of x there is only one value of y. So here this would be a function because one value of x only maps to one value of y. You can check it for every single one, even for this one. But then for this one, if you look, one value of x gives you two different values of y. So this would not be considered as a function, as I've stated here. Even over here, minus 9, this is the x coordinate values, remember, and this is y. So one value of x is being mapped to two different values of y. So that's why this is not a function. So why don't you try these problems on your own? Check if I will let you know the answers when you have finished. So you have to check whether these are functions or not. So you could pause the video. So I will tell the answers now. This is a function because one value of x maps to only one value of y if you check for all of them. And then this is a very special kind of function which we will do later. Only one value of x is being mapped to only one value of y. So this is a function. How about this? No. One value of x is being mapped to multiple values of y. So obviously this is not. So even this is true for this one because 1 is being mapped to minus 0 and 15. So this would not be a function. And this one, this would be a function because one value of x correlates to one value of y. Okay, the next part is type of relations or also functions. The first one is called as a one-to-one. This would be a function because one value of x maps to only one value of y. I mentioned previously that this was a special type of function because of this. It's called as a one-to-one function. The second one is a many-to-one, meaning many values of x can map to a single value of y. This would be a function because because it's a many-to-one, meaning that two different values of x map to one value of y. Here we could take y equals x squared, meaning if you put x as 1 or minus 1, the answer would be the same. So this would be a many-to-one function. The last example, it's one-to-many. This would not be a function because one value of x maps to two different values of y. Since we mentioned over here, it does not fit this criteria, right? So that's why that would not be a function. So one-to-one, many-to-one are functions, and one-to-many and many-to-many are not functions. They would be relations. But the thing is, many-to-many is not in like the syllabus. It basically states that like many values of x map to many values of y. That's basically it, but it's not part of the syllabus, so I'm not going to go deep. But we can, for one to many, the examples would be y equals plus or minus square root of x. Even if you put the value as 1, x as 1, you'll get two values of y, which is plus 1 and minus 1. Therefore, it would be called as a relation and not a function. Just remember, these two are functions, this one is not. Okay, to check whether a relation is a function, we would use something called as the vertical line test. A vertical line test is used to see if a relation is a function or not. So that's, yeah. So we'll have to draw a vertical line over the graph that you have. And when we draw a vertical line, if the graph cuts the line at two or more points, it's not a function. So if you draw a vertical line anywhere here, this is it cuts at 1 point, here 1 point, here 1, here 1, 1 and 1. Therefore it would be a function. But over here we have drawn that vertical line, but it cuts the point at two different points, so that would not be a function. The explanation is pretty simple, that a single value of x maps to two different values of y. As we saw, this would be considered as a one-to-many, meaning one value of x maps to two different values of y in this case. It can map to like many values of y. And hence this is not a function and this is a function. So you can try these problems on your own, these 5 problems, and I'll tell the answers. You can pause the video because I'm going to tell the answers right now. Okay, the first one is not a function. It's kind of easy. Just draw the vertical line. It cuts at 1 and 2. And this is a function because it will only cut at 1 point. This one, it is not, because if you draw a line here, it would cut 1 and 1. So that would be 1 plus 1, 2. This one, definitely not, because it does not cut at 2 or more points. This one was definitely slightly tricky because these points I haven't really explained them. So basically an open circle means that the point is not included. A closed circle means that it is included. And yeah, and the arrow means that it will continue in that direction. So this would not be a function actually, because if you draw a vertical line here, meaning that this point and this point are included, so the vertical line is cut twice, one here and one here. But here it's being only cut once, so it's here. So if this part of the graph wasn't there, this would have been a function. Okay, the next one is a horizontal line test. This is somewhat similar to the vertical line test, but here we are checking if a function is a one-to-one function or not. So what we'll have to do is very similar to the vertical line test, draw horizontal lines instead. And we'll have to see if the line is being cut twice or more than that. So here it's only being cut once, so it would be a one-to-one. Whereas over here, if we draw a line here, it's being cut thrice, 1, 2, 3. Even over here, it would be cut twice. Therefore, it's not a one-to-one function, but rather it's just a many-to-one. One-to-many function. Sorry, many-to-one function. Okay, you could try these problems on your own. Okay, I'll tell the answers now. If you haven't done it, just pause it and do it right now. So here, if we draw a horizontal line here, every single point is on that horizontal line. So therefore, it's not a one-to-one function, but it is a function because it passes the vertical line test. And this graph, it would definitely be a one-to-one function because it's being cut only once if we draw the horizontal line here. And also it's also a function because it passes the vertical line test. And this one, it's not a one-to-one function because if we draw a horizontal line here, it's being cut thrice here, twice here, and twice here. This point, it's not. I mean, it is a one-to-one function because if we draw the horizontal line, it's being only cut once. And this one, no, it's not a one-to-one function. Okay, the next part is function notation. It's like there's really nothing to explain here. It's just that you'll have to replace y with f of x. So that's all. Like you just write the value of x within here. And if you want to replace with 2, like x with 2, you'll have to write f of x equals 3 into 2 plus 3, which is 6 plus 3, that is 9. That's all there is to this.